in progress.
Good afternoon. Today we continue chapter 12. Last class we talked about binomial tree and based on the assumption which is no arbitrage argument. Today we're going to talk about the other approach, which is we're going to use risk neutral valuation to find the option price. Okay, so let me share my screen. Can you see my shared screen, please? Yes?
Yeah.
Okay, thanks. All right, so when we value a derivative, we can make assumption that investors are risk neutral. In reality, investor can be very different, right? Can be risk neutral, can be risk loving, or risk averse, right? So some investor doesn't like risk. But for this model, for the binomial tree model, we assume investors are risk neutral, which means it's okay, right? Risk, no matter risk how high the risk is. So it means that investors do not increase the expected return they require from investment to compensate for increased risk. Okay, so this is about the risk neutral explanation. A risk neutral word has two features that simplify the price of derivatives. That is, first, the expected return on a stock is the risk-free rate. Okay, so this is very important assumption. The expected return on the stock is risk-free rate. And the discount rates used for expected payoff on option is also risk-free rates, okay? Because we assume the risk neutral. Okay, so since the expected return is risk-free rates, so when we value option in terms of the underlying stock, the expected return on the stock is, which is expected return is irrelevant. We use the R as risk-free rates. Okay, we use small r, which is the risk-free rate, which if it's capital R, that's expected return. So in this case, we basically assume capital R equals small r. So expected return on the stock, is risk-free rates. Okay. expected return on the stock is the same as the, which is risk-free rate. Okay, so we assume that. And here the formula basically define what? Expected return, expected the value, right? Expected price, let's say. E means expected. The ST, which is stock price at the expiration day time T. And we calculate that value, basically, if you draw the timeline, 2 times 0 and T. So we know the stock price today and how to find the stock price in the future, because stock price in the future, we don't know today. So we only can expect it, right? We can estimate that. So expected return calculated by based on the stock price today, and we do continuous compounding. Okay, so S0 do continuous compounding by T period. So that's the how we get the expected value at the time T for stock. Okay, so this is about the stock return. The application of risk neutral valuation. So basically say the value of the option today. Okay, that's what we are looking for, right? The value of the option today, which is F0, and should be is the expected payoff. Okay, so we should find out the expected payoff at the time T. And in a risk neutral world, we can discount this expected payoff at the risk-free rate back to time 0. And that's the value, which is the option price today. Okay, so that's basically the key idea about the risk neutral valuation. So we need to find the expected payoff. So this is very similar to the risk, no arbitrage argument we did the last class, right? We also find the expected payoff, but at that time we do portfolio, right? We do portfolio. Here we are not doing portfolio, we separate stock and option. Okay, so to apply risk neutral valuation to the pricing of a derivative, we first calculate the probability, because we consider only 2 possible for the stock price go up or go down. Only 2 possibility, okay? And what we are looking for, which is the first step, we need to find out the probability. For example, probability, we use P. When stock price going up, we assume that's P, which is the probability of stock price going up. Since there are only 2 cases, so the other case, the probability would be what? 1 minus P, right? So that's the probability, consider 2 case. So first to calculate the probability of different outcome would be if the word is well risk neutral. Okay, then we calculate the expected payoff from the derivative. Okay, discount the expected payoff at the risk-free rate. That's the option price today. Okay, so let's see example and how we're gonna apply this valuation. So basically we're gonna do 2 steps, okay, rather than 3 steps. The first approach, we talk about the 3 steps, right? And the second approach, we're gonna use 2 steps. So example 3, a stock price is currently 20, okay? You can draw the binomial tree. Okay, so S0 stock price today is 20. It is known that at the end of 3 months, so you know what is T, right? T equals 3 over 12. And it will be either 22, okay, stock price going up is 22. If all 18, so stock price going down, that's 18. So we know stock price today and in the future, right? So that should be given in the question. The risk-free interest rate is 12% per annum with the continuous compounding. Some students like do question use the just the symbol compounding or discounting. Is do annual or period. That's not correct. Okay, we should do, in our class, we always do continuous compounding. Okay. Question 1, what is the value of a 3-month European call option? So first, this is call option, okay? With the strike price 21, so that's K. Using, you need to read the question carefully, okay? Using risk neutral valuation. So if the question asks you risk neutral valuation, but you didn't know arbitrage argument, then you're totally wrong, right? So read the question carefully. Use risk neutral valuation. And then question 2, verify that no arbitrage argument give the same answer. So that means you use the approach 1, use the first approach we talked about in last class. You should get the same answer, and the question 2, which is ask you use the approach, the first approach, okay, to find the option price. And this you can find from example 1. Because the question is exactly the same. And at that time, we find the call price, which is F0, is, can you go back to the example 1, see your notes, what the option price you got over there. You can check your notes and tell me what's the option price for example 1 we talked about last class. I just want to double check you made notes and you understand. What's the answer for example 1? Anybody can tell me? Anybody know? Kevin?
What was the question? Sorry.
The question is, last class we talked about example 1. Can you find your note and see what's the answer for example 1?
Yeah. So would it have been at the end of step 3?
Yes.
So I had 0.633.
That's correct. Good. Thank you. 0.633. Okay. So that's question 2 we basically did already. And question 1, we're going to use what we learned from today's class and double check the option price is also 0.633. Okay. So we're going to do 2 steps. First step, step 1, find the probability, find the P, which is the probability, when stock price ST goes up. Okay, so this is the P. When stock price go up, we want to find what's the probability. Okay, and then the other case, when stock price going down, the probability would be 1 minus P, right? Because only two cases. So and we call this P is the risk neutral probability. Okay, sometimes we call it the risk neutral probability. So to find out that, we basically do left-hand side and the right-hand side and make them equal. And left-hand side, we start from the stock S0. So we know based on the stock price today, we can calculate expected stock price ST based on S0, do continuous compounding for time T, right? So that's the expected return based on stock price today. And the other, the right-hand side, we're gonna calculate the expected payoff, expected value, or also expected price for stock based on the probability. So that's, you should learn from Finance 312, which is the expected value based on the probability. We do probability times when stock price go up, the price is 22. Okay, and then when stock price going down, that's 1 minus P, the probability 1 minus P, and then times 18. Okay, so right-hand side is also expected value, and the left-hand side is expected value. So they should be equal. So what we are looking for is P, right? And then we're gonna first get left-hand side is 20. Our interest rate 12%. T is 3 months. So 22P plus 1 times 18, so that's 18. And the minus P minus 18, so minus 18P. So 22P and 18P, you can combine, right? You can combine, that's 4P and plus 18. So left-hand side, what did you get? And then find the P. Can you do the calculation? Please do the calculation and tell me what did you get for the left-hand side.
I got 20.609 for the left side.
You get a 20.609. 609. Okay, 61. Good. Thanks. Thank you. So and then we're gonna do what? You can move 18 to the left-hand side, right? So 4P equal so you do the calculation. 20.61 minus 18. That's 2.61. And P equal what? 2.61 over 4. You should get the 0.6525, right? But in my question, I got 0.6523. It's just a rounding. Okay, you can use 23 or 25. If you keep 0.9, if you keep 0.9, you probably get the okay, so it should be 0.6523, right? Okay. So that's first step. Find the probability when stock price go up. We call it the risk neutral probability. That's first step based on the stock information. Okay. And step two. Step two, we're gonna find the option price. Okay. And we need the information from the first step, which is the probability. Now we can draw the binomial tree for option. So today, option price, this is what we are looking for. And when stock price go up, we need to because this is call, right? So the expected value for the option, we calculate by ST. If stock price go up, minus K and the 0. Stock price going up is 22 and the strike price 21. 22 minus 21, that's what? Equal 1, right? 22 minus 21. And when stock price going down, that's 18. And the strike price is 21. So 18 minus 21, that's negative. So we take a 0, which is the higher value, right? We take a 0, which is the higher value. Okay, and then we can set up the equation, right? We can set up the equation. We wanna so again, the probability go up is P and the going down is 1 minus P. So we can set up equation. Left-hand side is F at option price. And the right-hand side, we first need to find the expected value for right-hand side. Expected value at the time T, we do what? The probability stock price go up times the value for option, which is 1, and plus 1 minus P times 0, because when stock price going down, this is the expected value. This is the right-hand side expected value at the time T, right? We need to discount this value back to time 0. So we need to do continuous discounting, make sure negative RT, okay? And then left-hand side, right-hand side, both time 0, okay? Both the value at the time 0. So P, we find the P from the step 1. We can plug in the equation. So 0.6523 times 1, which is 1, and 0, the second component is 0. So we do continuous discounting, which is negative interest rate 12%, and the T is 3/12. So can you calculate the option price?
$0.633.
Oh, that's good. Yes, exactly same, right? So you see this two, exactly same. No matter you use approach 1 or approach 2, you should get the same answer. Okay, that's good. So in your assignment, you're gonna see similar question, which is ask you use either no arbitrage argument or use risk neutral valuation and find out the value of the option and compare this to the answers, and you should get the same answer. If you didn't get the same answer, there must be something wrong, right? So you need to double check. Okay. Any question? Any question? So the slides, my slide shows the step 1. You need to calculate the risk neutral probability. Okay, so calculate the P. P is risk neutral probability, which is when stock price go up, what's the probability for a stock? So first we consider the stock option, the binomial tree. The value of the stock in 3 months would be so this is the expected return at the time T, and this is also expected return, expected value of the stock at the time T. So you can find the probability. Okay. And once you find the risk neutral probability, we're going to use that for option. Okay. You're going to use that for option. For option, we know the probability, and also we know the value of the option in 2 cases, because we know stock price and we know strike price. So the value of the option in 3 months, we're going to calculate the expected payoff. So this is the expected payoff based on the probability, right? And then we discount this back to time 0. So this is continuous discounting. Okay, this is continuous discounting. Okay, that's continuous discounting. And since the payoff is 0, so the second component is 0. And you can find the option price, the value of the option is 0.633. Question. Okay, in next slides, we have one more example, which is about the put. And this example, which is different from the previous example, we do not have a similar example for this, but so we're gonna do 1 and 2. So the question 1 asks you use the risk neutral valuation, and the question 2 asks you use no arbitrage argument to see you can get the same answer. This is about the European put. Okay, so let's do the question 1 first. A stock price is currently 80. Okay, so step 1, you need to find the P, right? Which is the risk neutral probability. Based on the stock price today is 80, and the stock price go up 85 or 75. So we are looking for the probability P and 1 minus P, right? So we can set up equation. Left-hand side, based on the stock price today, we can do continuous compounding to get the expected value at the time t. And the right-hand side, we can based on the probability, which is the probability times price plus 75 times 1 minus p, right? So right-hand side is about the p. So p is what we are looking for. And the left-hand side, we know stock price 80, interest rate 5%, t is 4 months. So can you solve this equation? Tell me, what did you get for p? So tell me, what is p you get? Probability. So probability, just to keep like 4 decimal, okay? 4 decimal for probability.
.634.
Yeah, 0.634. Can you keep a 5 decimal?
One more decimal.
Yes.
Okay. 0.63445.
Yeah. So if you keep 1 more decimal, which is 45, right? Yes. 6345. If you didn't find this answer, can you double check? Yes, please double check. You can get the same number. Okay, step 2, which is we are looking for option value or option price. So we're gonna set up a binomial tree for option. Today is F0, that's what we are looking for. And at time t, which is 4 months, we need to find the payoff, which is based on put, and we're gonna do K minus ST, right? When stock price go up and 0. And when stock price going down, which is K minus STD 0 for the value of the option at the time t. So can you tell me what's the value? What's the expected payoff when stock price go up or go down? K is K. What is K? K.
High.
Yeah. No. Strike price 80, right?
8.
Yes. Strike price 80, and when stock price go up 85. So 80 minus 85. That's what?
Negative, so 0.
Yeah, that's correct. So when stock price go up, the payoff of the put option would be 0. And when stock price going down, what would be the payoff for the option?
5.
Yes. Okay, so because the K is 80 and the stock price going down is 75. So 80 minus 75, that's 5. Okay, that's good. And then we're going to set up an equation for time 0. That time 0 left-hand side, which is option value today. This is what we are looking for. And the right-hand side, we're going to find the expected payoff based on the probability and the payoff for either case. So probability times the price go up, 0. And the 1 minus P, which is the probability when stock price going down, and the payoff is 5. So this is the payoff at the time T. So we cannot compare like the value at different time, right? So we have to discount right-hand side back to time 0. So negative RT. Right-hand side 0 times P, that's 0. 1 minus P, we know P is 0.6345. So 1 minus 0.6345 and times 5. And this value do continuous discounting R 0.05. T is 4 months. So tell me what's the option value?
Is it 1.7973?
Yeah, you are there very faster. So 1.8. Okay, you can keep 1 decimal or 2 decimal in the last step. Yes, 1.8. So you can see this is the approach we talk about today, and we just need 2 steps, right? 2 steps. First step based on the stock binomial tree, and we find out the risk neutral probability. And step 2, we need to find the option value, or say option price, based on the binomial tree for options. Okay, any question? Okay, so this is about the question 1, and we know the price is the option value is 1.8. So I'm gonna need the space for question 2. We want to see can we get the same answer, which is 1.8 for question 2. Okay, so question 2 asks you to use no arbitrage argument to get the same answer. And remember, we talked about last class, step 1, we need to set up a binomial tree, right? Set up a binomial tree model. For stock and option. So we did it in the first question, right? Stock price today is 80, and the stock price going up is 85 or 75. And the option today's price is F0, and when stock price going up is 0, when stock price going down is 5, right? Remember? That's what we did in the first question, so we can quickly figure it out. So step 2, we're gonna create the riskless portfolio, right? We're gonna create a riskless portfolio, and we're gonna do what? We're gonna short the other shares, right? We don't know what is the other. What we're gonna find it. We're gonna short the other share and long one put option, right? This is put, right? Yes. So to set up this, we can create the value for the portfolio in the binomial tree. So we do short delta, so short, which is negative, and we know the stock price today is 80, so 80 delta, that's for stock, and the put today, which is the one put, which is F0, right? So this is binomial tree for portfolio time 0. And the time T, we're gonna do delta. So the price, when stock price go up, which is negative 85 delta, right? And the option payoff is 0 when stock price go up. Okay, so we can skip that, that's 0. And when stock price going down, which is negative 75 delta, and the payoff for option is 5, so we're gonna plus 5. Okay, so since we have assumption with no arbitrage, so we can set up equation based on the payoff at the time t, so which is negative 85 delta should equal negative 75 delta plus 5. Can you find the delta for me? What's the delta?
0.5.
0.5. Can you check it again? If you move 75, negative 75 delta to the left hand side, then
Oh, it's negative 0.5.
right, that's correct. Okay, don't forget the negative 0.5 because you do short. So delta negative means it's the short 0.5 shares and the long one put option. Okay, so once you find the delta, we're gonna put this number back to the payoff in the binomial tree. So delta is negative 0.5. So the payoff at the time t would be what? Negative 0.5 times negative 85. So 85 over 2 equals
42.5.
42.5. Yes, that's correct. What about the when stock price going down? Is that same number?
Yes, it's the same.
Okay, good. So you need to double check. You should get the same answer. Okay, and the stock price, and also we need to find the payoff, the value at the time 0, and to replace delta. So delta is negative 0.5 and times negative 80 plus the option value. So would be 40, right? Plus F0. Okay, that's step 2. We done step 2, and we're gonna do step 3. Step 3, we're gonna set up the equation, and based on the expected payoff, we find is 42.5, right? And the time period is 4 months. And the portfolio value today is 40 plus F0. So you can do discount or you can do compounding. I think you do discounts, that's easy. So left-hand side 40 plus F0, that's the portfolio value today. And they should equal the expected payoff 42.5, we back to time 0. So do continuous discounting, negative RT. Okay, so the option price today equal 42.5, and R is 5%, T is 4 months, and minus 40, right? So can you find the option price in step 3?
$1.80.
Yeah, so you get the same answer, right? So 1.8. So we basically verify that the answer should be equal, no matter you use risk neutral valuation or no arbitrage argument. You should get the same answer. Okay, so that's the key issue in this chapter. So you use different approach and you should find the same answer. Okay, that's very important. If you do the question, use different approach, you didn't get the same answer, then something must be wrong. Okay, you need to double check. Any question? So in your assignment, you're gonna have 1, 2, 3, 4. You have 4 questions. Okay, you have 4 questions, which is you're gonna use the either no arbitrage arguments or risk neutral valuation, or they might ask 2 questions. One is risk neutral valuation to find out the value of option, or you use no arbitrage to verify your answer. Okay, any question?
No questions.
Okay, good. So if you still have a question, you first can check the slides with the solution. I'm gonna post after class, and the steps I showed the step by step, and you need to understand, go through them. And if you still have a question, you can email me. Okay. So in this chapter, so to summarize. In this chapter, we talk about 2 approach. In the no arbitrage approach, we set up a riskless portfolio and consisting of a position in the option and a position in the stock. Okay, by setting the return on the portfolio equal to the risk-free interest rate, we are able to value the option. So alternatively, we can use the risk-neutral valuation. We first choose probability for the branches of the tree, so that the expected return on the stock equal the risk-free rate. Okay, so first step, we need to set up an equation and to find out the probability, risk-neutral probability, which is when stock price go up, what the probability. Once you find the probability for stock price go up, you can find out the probability for stock price going down, right? We then value the option by calculating its expected payoff and discounting this expected payoff at the risk-free interest rate. Right, since in the risk neutral world, everything we do is risk free, right? Risk free interest rate. So make our estimation very simple, very simple. Okay, but the reality that would be more complicated. Okay, question. No. Okay, so good. We finished the chapter 12, and the next class we're gonna talk about chapter 13. Okay, we're gonna start chapter 13. We're gonna cover chapter 13. So by the end of the week, you need to finish your assignment. Okay, your assignment due by the end of the week. And also you need to start to work on your project, okay, case. For each group, you just need 1 case. If you choose the case 1, I think there are 5 mini case. You don't need to do all 5. You just need to pick up 2 from 5 mini case, okay? And please focus on the exhibits in the case, which is either table or figures in the case. You should buy the case from the website I provided in the syllabus. You need to carefully go through all the case material, and especially spend time to understand all the tables and the figures. And in the presentation, I prefer you focus on those table and the figures to tell us what they are talking about. Okay, and in your reports, you can focus on answer question. Okay, so for after next week, we're gonna have a week, but I know Monday is holiday, so we don't have a class on Wednesday, but it's time for you to study to prepare for the project. So you need to have a presentation. So you're gonna have a presentation which is after let me see. I think it's the final week. you're gonna have a presentation. So each group we're gonna have like, we're gonna talk about that more later. It will gonna be 10 minutes. So that would be, I think it's in the week of 26. Okay, so we have 2 classes, and we have 7 groups. So we're gonna present. I ask you to send me the slides before your group present. So you need to make sure get the presentation slides ready, okay, before you present. And the report will be due at the end of the semester, which is I think it's April 28th, the last day of class of the school. Okay. So even you do presentation, you didn't complete that, but you still have like 2 days or 1 day. Okay. But if you need a longer time, just let me know. Any question? And make sure you have a group. Okay, you should sign up a group on my course. Make sure you have a group. Okay, otherwise you will not be able to get the group credits. Okay, that's all for today. Okay, if you have any question, just email me. Okay.
Have a great weekend, Professor.
You too. Have a good day. Bye.